Alright, here is a video guide for Notes 1.5, analyzing graphs of functions. I'm going to try to keep this short, so I'm going to skip through some of the notes parts because I already posted some written notes into Google Classroom, and I'm just going to try to work examples. So something like this, where it says domain and range, we did talk about it already in 1.4, but these are the ones I'm going to skip, and you can just go through the written notes that I posted, and I'm going to do examples. Okay, so the domain of this function here, domain is all possible x values in the function. So the furthest x value is -1, and it goes to 5. So it starts back at -1 and goes to 5. So we say the domain is -1 to 5. And I'm purposely using a bracket here for -1 because that's a whole point. That point is right there. And I'm using a parentheses for the 5 because that's an open dot. That's a closed dot. So that's the bracket. That's an open dot. And so that's got the parenthesis. And all those points in between there make up my domain. Alright, the range goes from top to bottom, or it's really the range of your y values here. So our topmost point is at 3, and our bottommost point is at -3, both closed dots. And so we say our range is from -3 to +3, both brackets because both closed dots. Then f of -1 is just evaluating the graph, reading the graph at that point. So at x equals -1, we are at +1. And so we get a +1. At x equals 2, right here, we are at -3. And so this equals -3. Okay, it's just analyzing what the graph is giving you here. Moving on to this problem, we have the domain, the range, and evaluating at f of 0. The domain here, again, it's from left to right. Our furthest left point is at -4, and that's a closed dot there. And so we start back at -4, and we go off to the right to infinity. And so we say -4 to infinity, and we use a parentheses for infinity because that's not a point we can reach, and so we have to use the parentheses. Okay? The range is pretty similar here. The range, the lowest point is at -4, and it goes up to infinity. Even though it looks like it might peak at some point, it's going to keep traveling upward to infinity, and so we do the same kind of thing. We say the lowest point is at 4, and that was a closed dot, so we use a bracket, and it's going to keep going up to infinity, and so we say infinity, and we use the parentheses again. Now for evaluating at f of 0, that means where x is 0, what's y, and it looks like y is at 2, when x is 0. Alright, moving on. Vertical line test, we've talked about this. We'll see it right here. It's saying which graph is a function just using the vertical line test. Well, we can see in A, it intersects here, and it intersects here. So that's a no. It's not a function. It fails the vertical line test. Here for B, if I draw several lines, each one of them is only hitting that graph at one point. So that's a yes to the vertical line test because it only hits the graph at one point. And then for C, you can draw some lines here and see that this is, again, yes, it's weird. It's a weird function. It's not continuous because we break the graph right there. So it's piecewise, but it's still a function because we still pass the vertical line test. Okay, zeros of a function, those are just notes. These are just meaning the same thing, so that when you find the zeros, when you find the x values, you're finding the x-intercepts, and we're just setting our function equal to 0. And that's what we'll do here. Okay, so we're going to set this equal to 0, and then we're going to need to factor. So what I do is 3 times 10 gives me -30, so I need to multiply to get -30, and I need to add up to get +1. So the two numbers that do that would be a +6 and a -5, and then I can break this in. I'm going to have to factor by grouping, and so this becomes 3x squared plus 6x minus 5x minus 10. We're going to group it like this, and so I'm going to pull out a 3x. That leaves me x plus 2. And I'm going to pull out a -5, and that leaves me with x plus 2. So we get 3x minus 5, and we get x plus 2 equals 0 now, which if I set both of them equal to 0, I get x equals -2 from this one, and I will get x equals 5/3 from the other one. And those would be my two x-intercepts, or the zeros of the function. For b, we need to set this thing equal to 0. And so the first thing I'm going to do is square both sides. So I get 10 minus x squared equals 0. Subtract over 10, we get negative x squared equals negative 10. Divide both sides by negative 1, we get x squared equals positive 10. Square rooting both sides, we get that. I actually get two answers here. We're going to get x equals a positive square root of 10, and we're going to get x equals a negative square root of 10 because of the plus or minus you get from a square root. Moving on to the next one, we got more zeros or more x-intercepts to find, and so we set them equal to 0. This one you could see it of two ways. You could do 0 over 1 and cross multiply here to get it. Or I always just think if you set the numerator equal to 0 and find the zeros of the numerator, then you're finding the zeros of the function. So I'm just going to set 2t minus 3 equal to 0. Add 3 to both sides, you get 2t equals 3. Divide by 2, you get t equals 3 over 2. Okay? Here, again, setting it equal to 0. You have x squared, so I'm going to factor out an x, so that's x minus 8. So then you got to set them both equal to 0. So x equals 0 and x minus 8 equals 0, which gives you then x equals 8, and those are your two x-intercepts there. We have more here, same kind of idea. You would set the numerator equal to 0 and solve, and you would set that equal to 0 and solve. I'm not going to do those two. If you want further guidance on it, just email me and I'll do that. Notes here of increasing, decreasing, go to the written notes to see that. Here we have just a couple of things. We have an increasing, and we have, I just want to write out how we could write out increasing, decreasing, or constant here. So in the first one, I make an I for increasing. And this one, if you want to read it from left to right, from negative infinity all the way to positive infinity, this function is increasing. And so I write it like this. And it's a little sloppy, but it's really meaning increasing from negative infinity to positive infinity. It looks like it's constant for a little bit here, but it's not. We don't ever really hit a constant with this function. It's truly increasing the whole way. Now for the second one here, you have increasing. It looks like you have increasing from negative infinity till you reach that point here at negative 1. And again, I'm going to use my x values here because I'm looking at the graph from left to right. So negative infinity to negative 1. It's also increasing from 1 to infinity, which is from this point here all the way to the right. It's going to be increasing again. But we do have this section here where it's decreasing, and that's going to be, it's decreasing from negative 1 to 1. And I'm not using brackets because I'm just talking about in between these points. All right, I'm just talking about in between them, so I'm using those parentheses. Lastly, we have, I won't write this one out, but you can see from left to right, it's increasing here, it hits constant, and then it starts decreasing here. If you want further guidance on this one too, further explanation, just email me and I can explain them a little more. Okay, relative minimum maximum, a note there, a note here about just making slopes of secant lines, and then we'll practice it here. So what I'll do on this problem is I'm going to plug in my x values, get y values, and then use those x's and y's to find my slope. So plugging in negative 2, I'm going to get, so f of negative 2 is negative 2 cubed minus 3 times negative 2. That's going to give me negative 8 plus 6, and that's going to give me negative 2. Plugging in 0, I'm going to get, so f of 0 is going to give me 0, because 0 cubed is 0 minus 0 is 0. And so now I have my x1, x2, now I have my y1 and y2. So this is y2, this is y1, and I can find my slope. If I write them out as coordinates before I finish the problem, it would be my x1, y1 was negative 2, negative 2. My x2, y2 would have been 0, 0. And now I can just do my slope formula, which is y2 minus y1 over x2 minus x1, which is 0 minus a negative 2 over 0 minus a negative 2, which gives me 0 plus 2 over 0 plus 2, which is 2 over 2, which equals 1. And so that would be my slope of that line, or that secant line between these points here on that function. Okay. For time reasons, I'm not going to do part B. If you would like to see part B, just email me and I'll make a video. Lastly, if my computer isn't frozen here. So lastly, even and odd functions, kind of like we did symmetry around the origin. If you plug in a negative x and it gives you the same function as before, it's an even. If you plug in a negative x and it gives you the function but the opposite, so the negative part of it, you have an odd function, and you'll see that with 17 here. So I'm going to plug in g of negative x, which then would give me negative x cubed minus a negative x. Negative x cubed is still negative x cubed, because negative x times negative x times negative x is still negative, and then that is plus x. Now this right here is the same thing as if you multiplied the function by negative 1. So that means it is the same thing as negative g of x, which means this function is odd. Because if you plug in negative x and you get negative g of x, plug in negative x and get negative f of x, they just changed it from f to g, that means it's odd. Okay? Now if we plug in negative x here and watch, we'll see what happens. So f of negative x, you plug it in, square it, plus 1. You end up negative x squared is really just x squared, because negative x times negative x is positive, plus 1. And that's the same thing as h of x. So I plugged in a negative but came out with the same thing as the original, so that means that function is even. I have a few more examples here for 18 and 19. Again, if you need to see those to have some clarification, just email me and let me know. Here is the homework. I haven't cut anything out of this one, so pay attention to the Google Classroom. I will post an updated homework with things cut out.